So back when we talked about scalar multiplication, I told you there were two different types of multiplication with vectors. One was scalar multiplication, and the other is going to be the dot product. So remember, scalar multiplication means you're taking a single vector and you're multiplying each of the components by the same number, and the result is a vector. Okay, what's happening is by multiplying by that number, it's affecting the length of the original vector. Okay, dot product is performed between two vectors and the result is a scalar or a number. Okay, so that is a big difference. Okay, so let's read about it. It says the dot product of two vectors, u, which has components a and b, and then vector v, which has components c and d, is denoted u dot v. Okay, that is pronounced u dot v. And it's defined as follows. Okay, so u dot v is equal to a times c plus b times d. Okay, so basically what you're going to do is you're going to multiply the horizontal components of your two vectors together, so that's the a times c part, and then you're going to multiply the vertical components together, that's going to be the b times d, and then you add the results. Okay, so that's what's explained right here. The dot product of two vectors is the sum of the product of their first components and the product of their second components. Okay, and this is a big thing right here in blue. The dot product of two vectors is a real number, not a vector. Okay, so that's big, big, big. Okay, when you do scalar multiplication, the result will be a vector. When you do the dot product, the result will be just a number. Okay, so let's do some practice here. In example 7, we have a few pairs of vectors that we will find the dot product for. Okay, the directions say find the dot product for each pair of vectors. Okay, again, if you look at parts A and B, you have two vectors and there's a dot in the middle. That is indicating that you need to find the dot product. Okay, so let's start with example A. We have the first vector, negative 3, 8, and the second vector is 7 and 7, negative 5. Okay, so to do the dot product here, you're going to take the horizontal components. Let's multiply these guys together. This is going to be negative 3 times 7, and then we're going to multiply the vertical components together. This is going to be 8 times negative 5, and we're going to add the results. So this is going to be negative 21 minus 13. Okay, so this answer here will be negative 34. Okay, the answer is just a number. Okay, moving on to the second pair of vectors. Okay, we're going to do the same thing. Now we have 7, negative 2 as the first vector, and then 4, 14 as the second vector. We are simply going to multiply the horizontal components together. So this is going to be 7 times 4, and then we're going to multiply the vertical components together, negative 2 times 14. And then we are going to add the results. Okay, so this is going to be 28 minus 28. And so the answer, the dot product here, is 0. Okay, let's try the last pair. Okay, these vectors are given in ij form. Okay, but that does not matter. Okay, so our first vector is going to be 2i plus 4j in component form. That's 2, 4. Okay, and then the other vector is negative j. So that is 0, negative 1 in component form. Okay, so if it's easier to handle it this way, then do that. Okay, so now let's multiply the horizontal components together. So we're going to get 2 times 0, and then we'll do the vertical components, multiply these guys together. So this is going to be 4 times negative 1, add the results. So we're going to get 0 minus 4. So the answer here is negative 4. Okay. All right. So moving on to the next page. Okay, we're going to talk about some of the properties of the dot product. It says for all vectors u, v, and w and real number k, the following holds true. Okay, so it says, first of all, If you have u dot v, that's the same thing as v dot u. Okay, so what this means is the dot product is commutative. Order doesn't matter. Okay, so that's the first thing to know. Second, okay, if you have u dot v plus w, okay, so here you're adding the vectors v and w first to get v plus w, okay, and then you're doing the dot product on the left. Okay, so it's u dot v plus w. You can, in a sense, distribute here. This is going to be the same thing as u dot v, use the same sign in the middle, plus u dot w. Okay, so we can distribute, that's what this is saying. We can distribute the dot product. Okay, number 3 is very similar. The only difference is u and v are grouped this time, and then we're doing the dot product on the right, but we can still distribute here. Okay, this is going to be u dot w, keep the plus sign, v dot w. Okay, so again, this is the same thing. We can distribute the dot product. All right, and property number 4, okay, this is saying if we take a scalar k and we do the scalar multiplication, k times u, and that gives us a new vector. If we dot product that vector with v, it's the same thing as doing u dot v first and then multiplying that result, which is going to be a number, by the scalar k, okay? And it's also the same thing as first taking the vector v and doing scalar multiplication on it. So if you do k times v and get that vector, and then do u dot that result, you will obtain the same result. Okay, so what this is saying is you can move the scalar around, okay, essentially. All right, number 5 says, if I do 0 dot v, now be careful here. When you do dot product, you have to dot product vectors. So this is talking about the 0 vector. Notice the 0 is bolded. That means it's a vector. Okay, so this is the 0 vector. Okay, we know anything times 0 is going to give you 0, so the result will be 0. But remember, when you do the dot product, the result is a scalar or a number. Okay, so this 0 is just a scalar. Okay, so if you had to tell me something like this on a quiz or a test, if you need to refer to the 0 vector, you had better put an arrow on top. If you don't put an arrow on top, I'm thinking you're talking about the scalar. Okay, there is a difference and you need to indicate it. Okay, so if you dot product the 0 vector with any vector, you're going to get the scalar 0 as a result. Okay, the last property of dot product talks about what happens if you dot product a vector with itself. So u dot u, it's basically going to equal the magnitude of that vector squared. Okay, so if you dot product a vector with itself, the result is the magnitude of the vector squared. Okay, and you don't have to remember that, just do the u dot u, okay, but you're going to get a number. It just so happens that number is the magnitude squared. Okay, so let's try some of these properties out. In example 8, we're going to let the u vector be 2, -1, the v vector be 3, 4, and the w vector be -5, 12. And we're going to evaluate each expression. Okay, as we're going through this, you need to pay attention. Am I getting a vector as a result, or am I getting a scalar as a result? Okay, so in part A, we're doing u dot 3v. Okay, So we need to follow the order of operations. So I'm going to do what's in parentheses first. I'm going to go out to the side and do 3 times v. This is scalar multiplication, okay? So I need to get the vector v, which is 3, 4, and multiply each of the components by 3. The result will be a vector, okay? So this is going to be 3 times 3, and then 3 times 4. So after we do the scalar multiplication, the result will be a vector, and that vector is going to have components 9, 12. Okay, so that's what 3v is. Okay, so now we need to do u dot 3v. Okay, so I'm going to write down the vector u. The vector u is 2, -1. I need to dot that with my result 3v, which is 9, 12. So here we go. I'm going to take the horizontal components, multiply those guys together. So this is going to be 2 times 9. And then I'm going to add the result of multiplying the vertical components, -1 times 12. Okay, so this is going to be 18 minus 12. The answer here is a scalar, and the number is just 6. Okay, let's try one more. Okay, so this time we are going to first subtract. We're going to do v minus w. That's going to be a vector. And then we have to dot product that result with u. So I'm going to begin by doing v minus w. So I'm going to write down the v vector. That's 3, 4. I am subtracting the vector w, which has components -5, 12. Okay, so to subtract two vectors, I need to subtract corresponding components. So I'm going to take my horizontal components and subtract. In order matters, it needs to be v minus w. This is going to be 3 minus a minus 5. And then my vertical component is going to be 4 minus 12. So if we simplify, the vector v minus w is going to be 3 minus a minus 5. It'll become plus a positive. This is going to be 8, -8. Okay, so now that we have that vector, v minus w is 8, -8, we have to dot product with u. Okay, I'm going to write down v, well, I'll write the whole thing down, v minus w dot u. This is going to be v minus w, that's 8, -8. I'm dotting this with u. Okay, u is 2, -1. Okay, so the answer should be just a number. I'm going to take my horizontal components, multiply these guys together, so I'm going to get 8 times 2. I'm going to add the result of multiplying my vertical components. That's -8 times -1. My answer will be 16 plus 8. Okay, so the dot product here is 24. Okay.